So this is the last section in chapter 11. We're talking about essentially graphs with these rational expressions. Here's the deal. I would love to actually have you graph some of these by hand because that's really awesome. But again, ultimately, it kind of comes down to almost like we do the exponentials. If I did that, I would have you guys do a couple key points and then just do kind of an estimation of what the graph looks like. So instead, I kind of put this together where you will not ever have to draw or sketch your own graph, but you have to know a couple details of that graph. And again, for me, this is a really good, actually, I just described this chapter as a very in-depth introduction to rational expressions. So again, we're not actually doing the graphs, but in pre-calculus, you might. But honestly, most of the time, I don't know when the last time is I did a by hand graph of this. Most of the time, by the time you get here, you use either Desmos or your graphing calculator or something like that. To draw these graphs, or rather to interpret, because again, they all look a little bit different. But the things we're going to look for is the vertical asymptotes and the solution/roots. AKA the x-intercepts, and I should have changed that. I need to write that down because from here on out, I pretty much exclusively call those x-intercepts. So the vertical asymptote is the vertical line that your graph jumps up or down when the variable is undefined. So just a quick little thing that you don't actually need to know. Most graphs, I'm not going to say all of them, but look something like this, where it'll draw this curve, and when it gets down here, it jumps way up here and keeps drawing it over here. That's the asymptote. You guys, we already talked about with exponentials, we talked about a horizontal asymptote. That was that line that the exponential will get really close, but it'll never cross. It's the same thing now, it's just a vertical asymptote. So these, this is just really quick graph that I drew. Those two lines or those two curves come really close to that dotted line, but they'll never cross that. So that's what a vertical asymptote is. It's semi-familiar because we already talked about a horizontal asymptote. The x-intercepts are whatever makes the numerator 0. Did I put over here? Okay. So ultimately, that makes it seem more difficult than it actually is, because really, if the numerator, wherever the numerator is 0, that's your x-intercept. Wherever your denominator is 0, that's your vertical asymptote. So your numerator, whatever that makes it 0, that's your x-intercept. That's where is your x-axis. Wherever your denominator is 0, that is where your vertical asymptote is. And that makes sense because wherever your denominator is 0 is undefined. You can't have a point there, so that's why that ends up being that asymptote, because it never actually crosses that. Is that you can have multiple or none of each of those. There are problems that you don't have an x-intercept for whatever reason, or there are problems that you don't end up having an asymptote somewhere. But there are also ones you could have multiple. You could have 2 or 3 vertical asymptotes. You could have 3 or 4 x-intercepts. It all just depends. So if you get one of those, don't fret. So the first part, how to find your vertical asymptote, which again, I need to plus in the vertical asymptote, not to insult your intelligence, but one has to one because the other is pretty similar. So this is also how to find your x-intercept. But again, just like I put in that box, your vertical asymptote is what makes the denominator 0. 0, go ahead and solve. 2, so your asymptote is x is equal to -2. Try to remember your x is equal to. I'm not going to be super finicky about that this year. Next year, I'm going to be a little bit more finicky. But your asymptote is a vertical line, and so it's got to be x is equal to something. What about your x-intercepts? Well, your x-intercept, just like I said, your x-intercept is what makes your numerator 0. X plus 4 is equal to 0. X 4 from both sides. -4. Again, your x-intercept, x is equal to -4. Or if you just that one, if you put -4, it's not as big of a deal. This year, figure out how strict I want to be next year on those. That's all there is to it. Now, obviously, you guys all probably know, and if you probably can sense this, eventually we're going to be factoring more before we get to that point. So number 2 is, again, a little bit step harder, but it's just getting into where it's already factored. So the vertical asymptote is what makes the denominator 0, so x plus 1, what makes that 0? And 5x minus 3, what makes that 0? Guess I don't need these parentheses. Because again, when we factor to solve, once we factor, we ask ourselves what makes each one of those binomials 0. The first one's not too bad. That is x is equal to -1. You guys probably already knew that. The second one, you might have to take some time to actually solve this. Add 3 to both sides. 5x is equal to 3. Divide by 5. We get 3 over 5. That's a really weird vertical asymptote, but we're not graphing it, so that's fine. If we were graphing it, that'd be a little bit more difficult. And then your x-intercept, again, the same thing, except for it's with your numerator. So what makes that equal to 0? Well, that would make what makes x minus 2 equal to 0 is 2. So your x-intercept is at 2. And the other intercept, what makes x plus 4 equal to 0? Again, you don't actually have to show all your work for this, but that is -4. So we have 2 asymptotes and 2 x-intercepts. Yeah, I'm going to go ahead and do it. Basically, I should, as a good teacher, which I actually ever claimed to be, I should actually show you what a graph like this looks like. And again, all the graphs look different. This one's going to look way different than some of the other ones because there are 2 asymptotes. But if you go to Desmos, okay. So what did we have? This is where we're going to have to go back and forth. X minus 2, x plus 4. Sorry, I don't graph a lot without my... Oh, geez. That's not in the right order either. Oh, no, it's QWERTY. Okay. I probably should bail on this. X plus 2. X minus 2. See, I already messed it up. Yeah, I'm going to bail because I also need a fraction in there. Okay. It was a good thought. You can always graph these. And again, I should graph them so you actually have a general look of what that looks like. But that's okay. We all have room to improve. Again, like I mentioned earlier, we'll have problems, or most of the problems, number 3, where we have to factor first. So again, don't make this harder than it is. It's the same type of factoring we've been doing. You're not going to have anything with a leading coefficient. You're not going to have anything like sums and differences of cubes. So if you factor that, you end up getting factors of -6 to add up to 1. It's x plus 3 times x minus 2. Again, I encourage you to double check your work. It's -2 by 1. Factors of 8 that add up to be 6 are +2 and +4. Nothing cancels. We'll talk about that in a second. So, 0 is your x-intercepts. So that is x is equal to -3 and +2. That's your x-intercepts. And asymptote is x is equal to, we'll make your denominator 0, -2 and -4. Make sure you're paying attention to what you're actually answering because maybe I'm glad I did this. The ones before, the vertical asymptote was the first thing we found. So I definitely have had students that they think the first thing is always the vertical asymptote, and then they get to the ones that we just did where I accidentally flipped them. So just make sure you're aware of what you're actually solving for. But essentially, that's pretty much it for today. I guess we're going to talk about holes a little bit, and then we're going to talk a little bit about graph recognition. But if you understand this stuff, it's not going to get much more difficult today. So go ahead and do number 5 on your own. All right. So that's what I got for this one. Again, factor everything you can. If you can cancel, do so. We'll talk about that in a second. That's what we're going to do next. But other than that, whatever makes your numerator 0 is your x-intercept. Whatever makes your denominator 0 is your vertical asymptotes. Now, again, remember, you're solving. So a lot of people, when they miss this, they say their x-intercept is -4 because it's x minus 4. Remember, we're solving. We're setting those equal to 0. Also, because I know I gave you guys anxiety or on the edge of your seats for this, don't worry, figured it out. So I graphed all these. So that first one is what we had for number 1, x plus 4 over x minus 2. And this one we're talking about where you can see the asymptote would be a -2, and you can see that's where that jump is. Now I will say if you actually, well, maybe I should say, graphing calculators, they don't know how to do that jump, so it looks like there's a line there. I think the newer ones that you guys have, they're like rechargeable 84s that are color and all that good stuff. I don't know if they show that or not, but the old ones definitely would draw. I mean, I don't think I can draw on this, but they come down and then they draw a vertical line and then they keep going. So there is actually a jump there. You should go over that more often. The next one I was trying to graph and struggled and cried a little bit to myself. Number 2, it looks like that. So that's where there are 2 asymptotes, and you can see where those are at. But also there are 2 x-intercepts, so -4 and +2. And that's one of the reasons that it's really hard for me to show you guys how to sketch this by hand because they all kind of look a little bit different. The best way to do is to make a T-chart, which is equally kind of a nightmare. When we did number 3, looks something like this. Really weird. Again, that's not an asymptote since it's got kind of a curve to it. And then the last one that you guys did looks like this, where again it has 2 asymptotes, but it only has 1 x-intercept. So here's the deal. I know when you look at that, it's probably not helpful for anything, but I do think at least you kind of see the shapes or see kind of what asymptotes look like. You can see where the x-intercepts are. Because later I added, one of the things I didn't have when I did this before, I added a matching part on your worksheet, on the notes, and on the test, where you have to match the graph with the function. And so you have to know where the asymptotes are, where the x-intercepts are, all some of those details. So I think that's it. Okay, sorry, enough of that. Okay, so the next thing we're finding is whole. So a hole is a point on your function where the x is an excluded value, but it is not an asymptote. I don't know if it's a textbook definition, but this is the best way to technically describe what it is. A hole is a point on your function, but that point is an excluded value, so it's what makes the denominator 0, but there's not an asymptote there. So more is a occurs when a binomial cancels in the numerator and the denominator. Now, technically, it doesn't have to be a binomial, but for our purposes, it'll always be a binomial. So anytime you have something cancel in the numerator and denominator, so you have an x plus 5 in the numerator, x plus 5 in the denominator, so you cancel those, you're going to have a hole there. Anytime it cancels, that'll make it a hole, an asymptote. Now, again, another really quick note I put, if there is no hole, you can put NA or no hole for that. I have students that they get really confused. They say, wait, I can't find a hole for this one. Well, yeah, sometimes there aren't a hole. On all these we just did, there were no holes. I'll make a joke about the book holes. What was that? I think in my top left drawer, I maybe have one or 2 left. Oh, do this the exact same way we just did. Now I'm just asking those holes. Factor if you can. So it's x plus 4 over. Factor this. Factors of -8 to add up to 2 is x plus 4 and x minus 2. X plus 4 on top, x plus 4 on bottom, so they cancel. So all we have left is 1 over x minus 2. So maybe I should have specified Where there's no hole, put NA. Maybe I should have done that for all of them. If there's ever not an asymptote, you can put NA. If there's ever not a x-intercept, you put NA. And the reason I'm bringing that up is because if you look at this one, the x-intercept is what makes the numerator 0. We are looking at this one here. We're looking at our after everything canceled. Nothing makes the numerator 0. It's just 1. There's no variables out there. So this one, there is no x-intercept. So you can go ahead and put NA for that one. That doesn't happen very often, but it does happen. The problem is some people say there is no x-intercept, so they put a 0 for no x-intercept, but they don't realize that that actually answer looks like the x-intercept is 0. Anyway, don't put 0 for that. If there isn't one, put NA. So again, if you look, your denominator is 2. X is equal to 2. Do not include -4 in that because -4 is -4 is a hole for this one. So that ends up your hole x is equal to -4. I know that a lot of times you put x is not equal to -4. Honestly, I can live with that. But the big thing is you go back to whatever canceled. If that canceled, that is where your hole is. So maybe this is a bad idea, but let's see how skilled I just got at this. X plus 4, and in my denominator, I have x squared x minus 8. Perfect. So if you look at this graph, here's the other problem with graphing calculators, and I don't have one that does this yet, but they don't ever actually graph the hole. So when you use a graphing calculator, or if you think that like, yeah, once I get to where I can use a graphing calculator, this will be easy, you still need to know where those holes are. And again, I'm not actually sure why graphing calculators don't do that. Seems like if you pay like $100 for a graphing calculator, it should. But what do I know? I don't work for Texas Instruments. I probably could work for Cat because they're terrible. Graphing calculators or scientific calculators are okay, but they're graphing calculators. We won't. We can't discuss that without using improper language. Anyways. But that's all. Again, the only other thing today is recognition of where these are at in the graph and what the graph looks like. So pretty much it. I hope that's not too bad. Number 5, again, we're going to factor everything first. So that's x plus 2, x plus 3. Factors of 6 that add up to be 5. Factors of 30 that add up to be 4. If you can't, do not list out your factors of 30. As much as I said, be pretty good at this. With that, you guys should be pretty good at saying, oh, well, I can't think of it. I'll come up with it. Don't be scared. Say, when I say you don't have to show your work, that's fine, but don't be scared to show your work if you need to, for your benefit, not mine. So what? 1 and 30 is not going to work. 2 and 15 obviously isn't. 3 and 10 is not. Is this not factored? I messed this one up. Interesting. So one really quick lesson on this that we actually aren't going to ever have to do. If this were actually the case, I would use the quadratic function to solve that one, to find your asymptotes. It give you 2 answers. That was supposed to factor, and apparently I messed that up. That's okay. I didn't want to do that one anyways. That's very similar to a Casio graphing calculator. We're scrap it and get out of here. Hopefully this T1 are x minus plus 4, sorry, and x minus 3. Again, double check. 4 times -3 is -12. 4 plus -3 is +1. And x plus 2. I did this on purpose to make sure you saw some. There is nothing to cancel, so before you do anything, I already know there's not going to be any holes because there's nothing that cancels. So this looks a lot like the ones we did before. Your x-intercept is at -4 and +3, and your vertical asymptote is at -2. X is equal to -2, sorry. go ahead, do number 7 on your own real quick. And then we'll finish up. Those matching ones won't take long. All right, my aim is there. So I'm not going to go, I mean, I could show you this graph, but rather than waste my time doing that, I will just tell you a couple things real quick. So an interesting thing, if you graph this whole thing with the x squared minus 2x with the x squares and all that, and if you graph this one where it's just x plus 4 times x minus, or sorry, x plus 4 over x minus 2, if you graph both of them on Desmos, they would literally be identical. And the reason is the only difference between what we started with and what we ended with right here is the holes. And Desmos doesn't graph the holes. So that's why you have to be really careful, because some of your graphs will look literally exactly the same. One will have a hole and one won't. So that's sometimes the only difference. And the main reason I'm telling you that is because of this next part, this matching part. I think on your practice test it was, and I haven't made the test yet, but I'll probably do the same thing on the test, where I gave you 3 options, and every single one is the exact same graph. One just doesn't have any holes, one has a hole somewhere, and one has a hole somewhere else. That's what I did on your practice test. Again, I don't know how to decide it exactly with your test. But the punchline is, to find these, really the biggest thing is making sure you know how to find your asymptote, your intercept, and the holes. Now, again, if you can only find 2 out of those 3, you're probably good. Even if you can only find 1 out of those 3, you're probably okay. I guess it depends on which one it is. Number 8, the x-intercept is at -1. The asymptote is at +2, and there is no hole. So let's see. I think I would probably start with your your x-intercept being -1. Unfortunately, if you look, every single one of these has an x-intercept of -1, so that doesn't help us. So move on to your asymptote. Your asymptote is 2. So that's right here. Well, that looks like the asymptote for that one. That's right here. That looks like the asymptote for that one. Over here, the asymptote over here. So I know 8 cannot be C. That's ruled out for number 8. And that's honestly the way I would do these, is I would just do process of elimination. So I know it's one or the other. Difference then, if you look then at the third thing, the hole, there is no hole. Well, if you look at A, there is a hole. It's over here -3. And I maybe should have brought this up, but that's how we represent that. We literally just put like an open circle there. That just means there's a hole there. Letter B doesn't have any hole, so that has to go with 8. Going with B. I'm going to kind of erase some of this just so we have a little more. Number 9, and I should have given you more room. Sorry that I was kind of running low on room. But you factor first, so x plus 1, x plus 3. Factors of 3 that add up to 4. And the next one is x plus 3 times x minus 2. So the x plus 3's cancel, so you end up with x plus 1 over x minus 2, which ironically is what we just had. But to go through, your x-intercept is 1. We already had all the x-intercepts at 1. Your vertical asymptote is at +2, so again, C is already out for that one. And this one has a hole at -3 because that's what canceled. -3 canceled out, so that's why we end up with this hole, so 9 has to be A. Now, obviously, we know what this last one has to be, but just to make sure, this one ends up being x minus 3 times x plus 1, factors of -3 that add up to be -2. This one, we haven't done one of these today, but we've done a bunch of them already this chapter. That is a difference in squares. So with this one, the x minus 3's cancel. Again, right away, I already know that's going to tell us where our hole is. Our hole is at 3, so that confirms that. It also says your vertical asymptote is at -3, so that's over here. That's perfect. And your x-intercept is at -1, which is what we had for all of them. So 10 ends up being C for that one. Questions over? You guys work on your, there is, oh, I haven't posted it yet, I bet, but there is an exit ticket. You just have to give me a second. A lot of times I make those and I put them online, but I have to hit post in the morning. And considering the staple situation, I haven't gotten to that. But work on that, do your exit ticket. And then again, if you want to start working on your practice test, you can. You'll have most of the day tomorrow in class to work on that. You'll probably have some time on Monday to work on it. But again, we only have 2 chapters left, so I'll just remind you, if you're struggling and you really need to pass this class, the best way to do it is to not wait till Monday to do your practice test. It's to get it done before Monday so you can ask questions. The best students I have, or the best way to help yourself, get those all done, circle any of them you have questions on, and then you can ask those on Monday. I don't have a video yet for that practice test, but I will have the answer key up in a second.